Okay, so we can kind of verbally do this one.
Mhm.
They're asking you to like basically restrict your viewing window to -6 to 3. So anything left of -6 you would ignore,
Mhm.
anything right of 3 you would ignore.
Okay.
And so you're supposed to figure out, well, what's the highest
And lowest
point
point.
and lowest point? And it looks like the lowest point there is at -3. That and then and that's where it's tough when you've got the whole thing graphed, but the highest one occurs at 3.
All right, let's take a look here. All right, this statement, all right, maximum at the right endpoint, minimum at the left endpoint.
So, but again, so you got to be careful here because like it's 14 to 32.
Okay, so 14, and that's like for X, right? So
Yes. So it's like it looks like
like right
14.
here,
Yeah, it's gonna be a little higher. So that looks
and then
that's
it'll reach the endpoint, but then it'll start going up again.
right.
So it would be
Maximum at
maximum at
left.
the left endpoint,
Yes.
and then would it be a minimum?
It's just you're just choosing one of the statements. So there's a maximum
So,
at the
well,
left.
wait, so minimum at the right endpoint or critical point?
The maximum is at the left
Yeah.
endpoint, and then the minimum is at the critical point where the derivative changes direction.
Oh, okay. So it'll be 4.
Yes.
So this statement gives 31 to 46. So 46 will be the maximum. This will be the
Yep.
minimum. This starts at the maximum at the right endpoint. So these two can be eliminated. And minimum. How do you know if it's a critical point or a left endpoint?
Well, a critical point is where there's a min or a max. That's where there's a horizontal tangent, or where the derivative changes direction. So the only critical point
Yeah,
is at 30 in any of these. So if 30 is not your window, you don't have to.
it would be this, right?
Yeah. The correct way to do this is actually to just graph the part that is in that interval, like from 31 to 46.
Yeah.
So if you want me to share my screen and snip it, I can, but that would be the correct way to do it, to like, then you would visually be like, oh yeah, that's the min, that's the max.
Mhm. I think it's fun to just do it verbally right now. All
Okay.
right, so 15, 14 starts at the left end point and then it ends at 29. So there's not a critical point. So it should be 3.
Okay.
Statement gives the location of the global maximum, global minimal for 28 to 58. The maximum will definitely be 58 at the right end point.
Yes.
And
And so since 30 is included, there is a critical point.
okay, so it's maximum at the right end point. Okay, so it's 2.
Yes.
All right. Here we are now. Photosynthesis rate. At what time is photosynthesis proceeding fastest for T is greater than or equal to 0?
The answer is, where is the graph going up and to the right most steeply?
So
And like what I look at is it's more steep at 0 than even that where your cursor is, because where your cursor is, it's getting flatter.
yeah. So around 0 days.
Yes, we can try that.
Yeah, that does make sense. I mean, okay, so the leaf grows at a proportional rate for what interval of for what part of the interval is the leaf growing? When is it growing the fastest? It's growing over the interval from 0 to 50.
Perfect.
All right, so 0. Would it be like this?
Yeah, yes, that looks good.
Okay. It's growing fastest when it is 0 days again.
I'm sorry, yeah. Let me try that and see if, all right, so didn't like any of those. Oh, you know
Yeah.
what? I'm sorry. They're giving you the derivative. This is the graph of the derivative. Okay, so that makes more sense. So the graph you're looking at is the derivative. So when it's the maximum, is it's literally asking for the maximum, which is at 50.
Oh, that 50. Oh, So 50, 50, and
Now
then,
it's growing whenever the derivative is positive. The derivative is positive everywhere.
oh, so that's just from 0 to
0 to
200.
200. Yeah. Now it's growing fast. This is not a, yeah, it's, why did they ask me? Okay. They just want you to restate it. All right.
It's a little strange. Find the global maximum and minimum values of the function.
All right. So there are a couple of ways to do this. One is to do it by hand, which is what you're going to have to do when you have an exam. Hopefully you're doing well in the class grade wise. The other is to graph it. Graphing it's preferred when you have the right tool, meaning like a calculator or Desmos. So let me share my screen and again, kind of give you those options here if you want to look at them for this. So is your goal here tonight to just do it, or is it to do it by hand and really learn it? Like, or do you just kind of looking to
Do a
get,
little bit of both.
okay. So let me actually share another screen and it'll tell the answer, but might as well do that. So I'm just going to graph it for you. So it's x plus 16 over x, okay? But it's only for x greater than 0.
Mhm.
You can see here that this just has a minimum. There's just a minimum. Okay, and the minimum is the y value. The minimum is 8. Okay. There's
Okay.
no max because it goes up forever, and then it also goes up forever. Now, if I go back and share my other screen, we can confirm that with using some calculus here. So the way you do this is you find the derivative. The derivative is 1 minus 16 over x squared. You set it equal to 0. And when you solve for x, you get x equals plus or minus 4. Because x is only greater than 0, you exclude the negative one. So it looks like this. You're starting at 0, going to 4. This is at infinity. And you
Okay.
test points in between. And what you find is it's decreasing and increasing, which means that this is a min, but there is no max.
Well, I should put NA. Okay, so global
Yes.
max is 8, and then this is just NA.
Yeah. Now there are questions where it says, where is the min? Where is the max? This one is just asking for the max and for the min.
All right, here we are.
Right. So again, like depending on the difficulty of the problem, the derivative could be easy or hard to do. Trying to get this snipped in. Give me just a moment here. Having a little issue there. There we go. All right. So I'm actually going to just share I'm going to first share the graph, and then we'll look at how to do it by hand. So again, 3x over, and you want to use x instead of t here. 3x over 1 plus x squared, perfect. All right, so notice this has both a min, or max and a min, okay?
Okay.
Now you can just write those in, but we can also get them by doing this by hand. Let me show you how you would do that. I mentioned at some point, I said, like, the reason you're learning all these derivative rules is because you got to be able to do your derivatives really fast. You got to be able to find f prime of t, which is bottom times the derivative of the top minus the top times the derivative of the bottom.
Quotient rule.
Yep, over the bottom squared. And you got to do it fast because you're not just taking the derivative now, you're actually doing something with it. So this is 3 plus 3t squared minus 6t squared, and over 1 plus t squared squared. So the top simplifies to 3 minus 6t squared. And you set the top equal to 0. You're setting the whole thing equal to 0, but it's the top that you really care about. So 3 minus 6t squared equal to 0. And when you solve for t, you get t equals, did I make a mistake here? I did. It's 3t squared. Looking at the answer, I'm like, that doesn't work. So your answers are t equals plus or minus 1. Okay. And so you make this number line -1 + 1, and you go back to the derivative. You go back to this line right here, this 3 minus 3t² over 1 + t². And that's what you're testing. That's what you're testing in each of these intervals. You're testing, what happens when you put 0 in, or what happens when you put 2 in, or what happens when you put -2 in. Okay, and you're testing them here, and you just care about the sign. Okay, so the bottom's always positive. Is just basically looking at what does the top do. And you'll find that it is negative, positive, negative, which means that this is a min, which we already know, and this is a max.
For this one, we're just putting the X's in the answer.
No, and see that's the
Or-
mistake here. I mean, the max is at x = 1, and the min is at x = -1. You have to put that back into the function.
Oh, okay.
So it ends up, when you throw it back in, this ends up being 1.5 and -1.5. It's rare that they're actually just like opposites of each other. Usually it's much different.
All right, share my screen for the next one. Here we go.
Yeah, just give me 30 seconds here. Let me snip it. Or you're welcome to try graphing this one on your own. You'd obviously graph X instead of F, but just give me a moment here to get this one prepped up. But, or we can just do it by hand, I suppose. It doesn't really matter. All right, so do you want to do this one by hand, or do you want to do it with the graphing? What would you prefer?
I think graphing is fine here.
Okay, so let me share screen. All right, so the again, you don't use the F, you go 0.25x plus 1.7 over x squared. There is a bit of an expectation here that x is greater than 0. And maybe that's obvious maybe that's not obvious because it doesn't say, but it says that f is hours, so we assume time is positive. But nevertheless, I mean, having said all that, you're just finding the minimum. Now, this time it's actually asking for f. It wants the equivalent of f, which is the x value. So that's the 2.4 hours.
Okay.
And again, the graphing is really makes it like
Easy.
easy. It's I mean, I hate using the word cheating, but it's like you really don't even have to know calculus. It just does it for you.
Yeah, you just plug it in.
Yeah.
And there it is.
And there it is. And you think, oh, this is really tough. If you want to, I mean, you're welcome to throw that into the Desmos. That's all I'm gonna do is graph this thing again. And on the exam, they're gonna obviously say, hey, show your work, take the derivative, do it by hand. Make sure that you know how to do this one on your own. So again, do you want me to do this one by hand? Do you want me to graph it? What's your preference here?
Can we look at a derivative, please?
Sure. All right, so let me share my screen. All right, so you gotta take your derivative I prime right here. And so this first one is the derivative rule of log, or ln, which means it's 1 over whatever's inside. So 1 over s 1016 minus the derivative of s is just 1. The derivative of 1017 is 0. So when you just a tiny bit of simplifying, you get 256 times 1016 all over s minus 1, and you set that equal to 0. Okay, so when you solve this, you end up getting s equals 256 times 1016. And I think that's all it's asking for. I guess we can calculate that. Let me get back to where, Oh, I didn't grab that part. I don't, so I should have grabbed, if you want to share your screen again, I don't know if that is, I don't know if that
That's
is,
everything in there. I
but
don't know
I
why.
don't know if that's the answer or they want you to put that back into the original function.
There's. I'm not sure if it really tells you though.
We'll look at it together here. So see how S is the, I is the number of infected children
Yeah.
and S are healthy or are susceptible.
Okay.
So they want the number of infected children. So you have to actually take that number I just found, the 256 times 1016 and put it back into the original function. Okay. So
Okay.
so I'll grab my calculator here. 16, and then we've got 256 times log S divided 1016 minus S plus 1017. Small sign error log. What did I say? S? Yeah, there it is. Ooh. I'm gonna graph this one because I'm just not seeing what I want here. All right. Still not seeing what I want. So 256 natural log X over 1016 minus X plus 1017. Is that right? Looks right to me. Okay. There it is. Okay. We actually. Oh, you know what? The issue is I did not give you the correct derivative. So let me just update the share screen here. Thanks for being patient. Sometimes I gotta actually like work this out a little slower. So the critical point happens at 256, not 256 times 1016. It's a result of me not calculating the derivative correctly. Still with me there, Jack? I'm not hearing you if you're talking. Maybe you're muted.
Oh, it was me. Sorry, I'm still watching.
Okay, so the max here is at 256, but they want the Y value here, which is 408 point. Yeah.
So that's what you put for the maximum number.
Yes.
Oh, I see. So like, it's like the literal maximum, like on the graph. All right, here's the last one.
All right, so the last one here. Okay, so Q of 0 means you're putting 0 in for the value of T. So that's just a calculator problem. You just plug that in. I'm grabbing a snip here, and then I'll work through it. So let me share my screen. Okay. So as I mentioned, the first part here just says Q of 0. That all that means is you're putting 0 in for T. And believe it or not, this actually simplifies to 1 minus 1, which ends up being 0. We could also graph it and we'll see the same thing, but we can also do it by hand here. So to do it by hand, you take the derivative. That 35 is a constant, so it just comes along. The derivative of e to the minus t is minus e to the minus t. And then the next part here is derivative of minus e to the minus 2t. If you recall, it's always itself, and then you take the derivative of the exponent. So it becomes 35 minus e to the minus t plus 2e to the minus 2t, and you set that equal to 0. Because they're asking it for to 2 decimal places, this may actually end up just being a calculator problem. You would set this equal to 0, the minus e to the minus t plus 2e to the minus 2t. Problem is that there's not really a known way to solve this. So I'm going to jump right to I'm going to just share the calculator, yeah, and we'll do it that way. And I'm going to graph the original. So you don't graph the derivative, you can, but it's not the thing that's of interest. What is of interest is the original function. Okay, and I'm going to hit home because my window is really messed up. And there you go. You can see, oh, there was 0 to start. That's what we said. Rises really quickly. And so the where it occurs is 0.693. Okay, and then what is it? The maximum is 9. So I'm sorry, 2 decimal places of 0.69, and then the maximum is 9 there.
So the maximum occurs at what was it? It was like 0.8 hours, 0.68?
0.69.
0.69. Okay, so 0.69 hours, and then the maximum is.
It says round to the nearest. It says round to the nearest integer. It looks like it's 9.
Okay. In the long run, what happens to the quantity? So here's what it says. It just says the quantity approaches 0, 35, or reaches its maximum, or the quantity continuously varies between 0 milligrams and its maximum.
All right, look at the graph. If you're still seeing my screen, it goes up. So it does reach a max, but then in the long run, it heads back down to 0.
Okay. So in the long run, it just approaches 0, basically.
Yes.
Okay. And then what was the Q of 0, 1 again?
0.
Just 0. Okay. All right. That's everything I wanted to do today. Thank you so much, Matthew.
All right. Have a great night.
Do you think we could use this time another time?
Yeah, but we're gonna have to figure out something else because I can't keep pushing forward hours as I get busier in the semester. But yeah, just contact me and I'll make something happen for you.
Thank you. I appreciate it.
Okay. Bye now.
Bye. Thank you.